Today we'll be looking at MYTLS write-up for August year 2023 and crypto. Background. The challenge implements a custom protocol for communicating between a server and a client. It's similar to TLS 1.2 with the protocol TLS CDH RSA with AES 256 CBC and SHA, and provides mutual authentication as well as confidentiality, integrity, and forward secrecy. Key compromise impersonation KCI. As presented in this paper at the given link, an issue with this protocol is that an attacker can impersonate either the client or server if they have the private key of the other peer and the public key of the user they want to impersonate. This is because the protocol uses static Diffie-Hellman keys. Therefore, an attacker can compute the same shared secret as the other peer if they have the private key. This is not possible with ephemeral Diffie-Hellman key exchanges. The attack: server sends certificate, client sends a random string, server sends something random, ephemeral client sends public key, ephemeral server sends its public key. Both of them communicate their secrets. After completion, they'll run HMAC. Then they'll start exchanging data using AES and the secret as key. The shared secret is computed by the server with the following, and then the client with the following. Note that HKDF is a key derivation function. The star is exponentiation needed for Diffie-Hellman. See server.py for details. One might notice that a client that has a server key pair and the public key of the peer they intend to impersonate can compute the same shared secret at the server, therefore authenticating successfully and impersonating the peer. This allows an attacker to use the admin's public key to authenticate and get flagged if the attacker has server private, making the server private key. After successful authentication, the server allows to store files on its file system, providing the hash of the previous content of the file. This is a path traversal bug. This allows to write to arbitrary files. Additionally, there is a missing file truncation issue that allows the partial override files. This allows to leak the server private key byte by byte. An attacker can write //app/ server.ecdhkey.pem as storage slot and write a known payload that is 250 bytes long on the server key server private key file. At the next iteration of a similar write, the server outputs the SHA-255 of the known plain text and last byte of the private key. The guest ecdhkey.pem file is 241 bytes long, as it's reasonable to assume that the server key has the same length. Otherwise, some small brute force can determine the file length. Repeating this procedure allows to leak the entire key. The private key can be and used to mount a KCI attack and authenticate as admin to get flow.